Hi learners! In today's video, you will learn how to determine the measure of an intercepted arc in a circle from the measure of the inscribed angle or the central angle and vice versa. If your lesson is on circle and you are on determining the measure of the intercepted arcs and angles in circles, or if you have an assignment on this topic, or if you are preparing for a test in math or geometry in particular, then this video is for you. Okay, let us look at this circle and let us identify the intercepted arc and angle in our circle. This angle, whose vertex is on the circle, is called inscribed angle. The arc intercepted by this angle is called the intercepted arc. How is the inscribed angle related to the intercepted arc? The relation is described in this statement. The measure of the inscribed angle is 1/2 the measure of the intercepted arc. What does this mean? It is like this. If the inscribed angle is 40 degrees, then the intercepted arc is 80 degrees. Did you get it? What about if the intercepted arc is 100 degrees? What is the measure of the inscribed angle? You are correct. It is 50 degrees. Let us look at this other figure. This angle is called the central angle. Look at the vertex of this angle. It is at the center of the circle. The arc intercepted by this angle is also called the intercepted arc. There is a relation between this angle and the arc intercepted by it. It is stated this way. The measure of the central angle is equal to the measure of its intercepted arc. So, if the central angle is 100 degrees, the intercepted arc is also 100 degrees. Okay, these are the two angles we just discussed earlier. This time, we will label our drawings so we can give names to these angles and the intercepted arcs later. Let us put these angles into one circle. Can you identify the inscribed angle from the central angle? Spot the difference between the two angles. You're right. The inscribed angle has a vertex on the circle. This is angle CBD. On the other hand, the central angle has a vertex at the center of the circle, and this is angle CAD. Now, let us use the relation between these angles and the intercepted arc to determine the measures of the intercepted arc and or the angles. Let us look at the figure shown here. If angle CAD is 60 degrees, what is the measure of arc CD? Okay, where is angle CAD? What angle is this again? Right, this is a central angle. What again is the relation between the central angle and its intercepted arc? Therefore, the measure of arc CD is 60 degrees. What about the measure of angle CBD? Before you answer the question, let us look at the drawing. Where is this angle in the drawing? And what angle is this? This is where the angle is, and this is an inscribed angle. Where is the arc that is intercepted by this angle? Well, it's here. Earlier we got its measure, which is 60 degrees. What is now the measure of angle CBD? Remember the relation between the inscribed angle and its intercepted arc. Yes, the measure is 30 degrees. Okay, did you get it? If you have any questions, just write under comment below. We will do it one more time, learners. If the measure of the inscribed angle or angle CBD is 35, what is the measure of arc CD? You are right, the measure of arc CD is 70 degrees. What about the measure of angle CAD? Yes, the measure of angle CAD is 70 degrees. Great. Okay, let us solve another problem by applying what we just learned. But together with the angle arc relations we just learned earlier, you need to remember that the sum of the angles in a quadrilateral is 360 degrees. Look at the figure that we have here. Also, the tangent lines are perpendicular to the radius, thus forming a right angle, which is 90 degrees. So we have in the figure a tangent line and a radius of the circle, forming 90-degree angle. Here is the problem. Circle O is shown below. Segment PQ and segment PS are tangent to circle O. What is the measure in degrees of angle QRS? As usual, when we are solving a problem, we must read the problem. If needed, we read it several times to know what we are looking for, note what information are given, and find ways by which the given information could help us determine what we are looking for. First, let us determine what we are looking for. In this problem, we are asked to find the measure of angle QRS. Let us locate angle QRS in the drawing. Here is the angle. This angle is an inscribed angle and is intercepting RQS. We know that the measure of the inscribed angle is one half the measure of the intercepted arc. So if we know arc QS, we will be able to determine the measure of angle QRS, right? But we do not know the measure of RQS. Let us look at the figure closely. This arc QS is the same arc that is intercepted by angle QOS, which is a central angle. We know that the central angle and its intercepted arc have the same measure. That means that we must get the measure of this central angle so we can get the measure of RQS, which is needed to get the measure of angle QRS. Okay, let us look at angle QOS in the drawing. In the figure, the central angle, angle QOS, is part of quadrilateral PQOS. One thing we know about quadrilaterals is that the sum of its angles is 360 degrees. In quadrilateral PQOS, two of its sides are tangents to circle O. These are given in the problem. The other two sides are radii of circle O as shown in the figure. It is a fact that the tangent line is perpendicular to the radius of a circle. So the angle formed between a radius and a tangent line has a measure of 90 degrees. We have two of these 90-degree angles here. With that, we now have the measure of the three angles in quadrilateral PQOS. There's just one angle whose measure we do not know of, and this angle is also a central angle of circle O, angle QOS. Let us first find the measure of the three angles by adding them. So the sum of the three angles is 205 degrees. Since the sum of the angles in a quadrilateral is 360 degrees, we subtract 205 degrees from 360 degrees to get the measure of angle QOS. So the measure of angle QOS is 155 degrees. Since the measure of the central angle is the same as the measure of its intercepted RQS, then the measure of RQS is also 155 degrees. Wow, we're almost there. Since RQS is the same arc that is intercepted by the inscribed angle, angle QRS, whose measure we are looking for, we can now determine the measure of angle QRS, right? Remember that the measure of the inscribed angle is 1/2 the measure of its intercepted arc. 1/2 of 155 is 77.5, Bingo! Thus, the measure in degrees of angle QRS is 77.5 degrees. We are done and we have solved the problem. There you are, learners. Let us summarize what we have learned on this video. We have learned that, first, the measure of the central angle is the same as the measure of the intercepted arc. Second, the measure of the inscribed angle is one half the measure of its intercepted arc. Third, the sum of the angles in a quadrilateral is 360 degrees. Fourth, the angle formed between a radius and a tangent line is 90 degrees. Fifth, when solving a problem, you must read it and may read it several times to know what you are looking for, what information are given, and to figure out how this information will help solve the problem. Finally, make use of the figure that is given to fully analyze the problem. Okay, hope this video helps. That's it for now. If you have any question, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.